Hi everyone, welcome back to our lesson. Today, what are we going to do? We are going to start with you physics quick revision for mechanics. First of all, for mechanics, what definitions we have? So we have our list here. We should memorize them all, nothing to do. So for our final exam, we should know all definitions: friction force, normal force, frictional force. As you know, we have two types of frictional force: coefficient of friction, weight, and more. So we have these definitions. Please study, please try to memorize them all. Today, our quick revision, so let's continue. And Newton's first law, second law, third law, and Newton's law of universal gravitation. So we have these definitions. Please study, please try to memorize them all. When you check past papers, you see some kind of definitions mostly coming. For example, Newton's first law, second law, third law, mostly coming. Just remember, you can continue with definitions, but we should know all definitions. As you know, for this topic, 1 or 2 definitions coming with 2 marks for mechanics. All right, all definitions here, please study them all. And then, what else we have? Cases for calculating the normal force and frictional force. How we are going to calculate normal force? First of all, let's remember how we are calculating normal force. And by using normal force, we can calculate friction force if you have friction. If you don't have friction, you don't need to calculate, of course. So let's continue. Let's check now. First case, you have only one object, and then how can we calculate our normal force? As you see, normal force is equal to gravitational force, but we are using Newton's first law, even second law. Which one we are using? Newton's first law, of course. For normal force, Newton's first law. F net for perpendicular equals 0. And what we have, if I say up is positive, down is negative. So normal force you can show with Fn or just N. N minus Fg equals 0. Normal force is equal to Fg, it means M times G. So just remember, if you have one object, normal force is equal to mg. We are going to just use like this, but it's coming from Newton's first law. I hope it's okay. When you come this side, same calculation step by step, and finally you are going to get normal force equals m1 plus m2 times g. So this is our normal force with 2 objects. And we are going to calculate all of them normal force. After that, we are getting friction force. So what we have now, apply force this way. Now case 3 with apply force. As you see with components, we are getting, how can we get Fa plus? So let's learn how we are getting component of force, components of a force. So we are using F apply parallel. For example, we can use F apply times cos alpha, and then for perpendicular, F apply times sine alpha we can use. So as you see with normal force we have up. So as you see 2 forces, you can use Newton's first law one more time. F net, because object is not going up and down, perpendicular motion is 0, acceleration is 0. So you can write normal, let's say up positive, we are choosing our direction, up positive normal force plus F apply perpendicular minus Fg equals 0. So you can write normal force like this. Normal force equals, let's write nice one. Normal force equals, you are just taking F apply perpendicular Fg other side. Normal force equals Fg minus F apply perpendicular. So what we know, Fg is equal to m times g, and minus F apply perpendicular, what we said, F apply times sine alpha. This is my normal force for this case. And then when you come to other case, next one, now as you see direction of applied force different. Now as you say, F apply perpendicular just opposite direction of normal force. So you can say it is helping to gravitation, but if you start from here and carry on, you are gonna get your normal force equals m times g plus F applied times sine alpha. I hope it is clear how we are getting normal force for each. I hope you are okay. And then for inclined system, case 5. So how we are going to get normal force? So first of all, components already here. So you are using Fg, gravitational force, components of gravitational force. Which component we are using? Fg perpendicular. As you see, when you use Newton's first law for this system, Newton's first law, let's see what's going on. F net equals, F net perpendicular, let's say, equals 0. And then you can write F normal minus Fg perpendicular equals 0. So your normal force, Fn or n, you can say it's fine. Normal force is equal to Fg perpendicular. So Fg perpendicular, how we are getting Fg perpendicular? M times G times cos alpha. All right. For perpendicular, this is our F normal, mg cos alpha. For this system, mg plus fg, F applied, sorry, now F applied sine, and then mg minus F applied sine. This is our normal force. All normal forces for all cases. Till case 5, we have done. So next step, what we are going to do, if you have, maybe you are going to have just apply force here, this long process, but for now it's fine. You can study off, so quick revision, but unfortunately we cannot cover everything in one period. I'm trying to remind you what we know, what we have to know for each topic. All right, so first of all, we said we calculate normal force. Now we are going to calculate friction force for each. Okay, friction force for first one, case 1. What we know for friction force? Friction force is equal to coefficient number times normal force. So our friction force equals coefficient times m times g. When you get normal force, easy to calculate friction force. Sometimes they can give you coefficient number, ask you friction force, or they can give you friction force and ask you coefficient number. So how can we calculate coefficient number if they ask? Friction force over m times g. That's it. It's easy for you. So for this one, what's our friction force? Friction force is equal to coefficient times m1 plus m2 times g. As you see, just writing here for normal force, let me use this side for case 3, friction force. Friction force is equal to coefficient times what we have, mg minus F apply sine alpha. Okay, so this is my friction force for this system. And then when you come this side, friction force times by coefficient number times normal force. So let's use and let's write here. What we have, my friction force is equal to coefficient number times normal force. So you can write coefficient number times m times g plus now F applied times sine alpha. I hope everything is fine. When you come to case 5, let's write friction force now, coefficient number times m times g times cos alpha. All right, this is our first thing we have to know, calculating normal force for different cases. Normal force, we are using other forces, maybe gravitational force, maybe applied force, maybe both of them, depends on case. And then when you get normal force, easy to calculate friction force. So I think we have done cases for calculating the normal force and friction force. Coefficient number is times normal force. All right, let's continue with next one. Let's see what we have now. We can clear all and continue. Next slide, we have free body diagram and force diagram. So now we must just work on free body diagram and force diagram for different objects, different positions. For mechanics, what else they can ask you? Okay, let's continue. First of all, calculating friction force. I hope it's clear. Calculating normal force is done. And all definitions, you know. And what is next? Drawing force diagram or free body diagram, or maybe both of them. We don't know which one is coming, but we should know how can we draw force diagram and free body diagram. First of all, on the system, you can show all forces. It's up to you which method you are using is fine. Firstly, okay, first of all, what force we have? We have tension force this way, right? And then we have what direction we should know. M1 is sliding up. Okay, direction of motion is important. Why? Because friction force depends on direction of motion. So we have this way, friction force, and normal force always perpendicular to surface, remember that? And gravitational force always going down. So this is my FG. So you can draw force diagram by showing all forces. This is M1, this is M2, because M2 we have tension force this way, tension force always pulling, and gravitational force from center of object. Just remember that, please. If you are drawing force diagram, starting point for gravitational force, and then a friction force parallel to surface. Remember that. As you see, it's here, not on just somewhere else. All right. So that's important point. Normal force starting from surface and perpendicular to surface. So if you do this, are you getting full mark? No. Why? Because we should write all names of the forces. F, tension, or you can say tension, just T is fine. You can write any of this. What we have, tension force. Tension force, we should say. And what else we have? Fn, or just N, normal force. We should write all names. We must label them. Otherwise, you are losing your 1 mark. So F, or just small f. What we have? Friction force. Friction force, I'm writing names, all forces. What else we have? Fg. Fg, or you can show with another symbol, gravitational force. Gravitational force is next one. Please try to remember, just try to write all names, all symbols. Otherwise, you are losing your mark. Please remember that. So force diagram for both objects, I'm trying to show all different systems, but of course you have more. You can go to your, your past paper questions, and you can see other types of questions, but we are trying to have revision with you, quick revision, all right? So this is my force diagram. Let's see this side force diagram. M1 is here, all forces. This way we have tension force, and then now they said M1 is moving to the right. So direction of motion this way. Also friction force to the left. So we must just show all forces on the system first. As you see, we have Fg going down and normal force going up, and then you can draw your force diagram for M2. I think you are okay with force diagram. Only starting point for forces and gravitational force from center, friction force parallel to surface, just down here, and then tension force. Direction is important, always pulling, we said. Tension force for M2 is pulling, and then gravitational force always down, but start from center. Normal force, perpendicular surface. All right, it is all force diagrams. And then free body diagram. Free body diagram, you can just show like this, or you can just show with dots. It's much better, I think. You are showing all forces, tension force, and we have what we have, friction force. You can show with small f, and gravitational force is going down, Fg or W, you can use one of these is fine, and perpendicular to surface, normal force. After that, of course, we are writing all names. Force diagram, free body diagram, done. Let's continue with next one. Let's see what else we have. Okay, Newton's first law, second law, third law. You are using Newton's first law, second law, third law to calculate your acceleration or tension force. So Newton's first law for normal force. Do you remember that? We have done for normal force. Now for horizontal one, we can use Newton's first law also. Newton's first law, or in our definition also, we just give Newton's first law is here. F net equals 0. Newton's second law, acceleration equals F net over m. So of course we should know these definitions. And F net equals m times a. F net with Newton, and then mass with kg. Acceleration with meter per second square. So, and then another one for it's coming from momentum for Newton's second law. Net force is equal to the rate of change in momentum. What was the rate of change in momentum? It was force, net force, right? Net force is equal to rate of change in momentum. That's another definition for Newton's second law. So these all definitions, all formula here. Let's continue. Newton's third law. Newton's third law, another definition we should know when a body, just you know all details, you please study, please try to memorize, nothing to do, sorry about that. So action and reaction force, we say action and reaction force, another one. And you can use this one to get delta, maybe velocity, maybe you can use another one, you know, it's coming to motion now, so get delta x maybe. So Newton's second law contains Newton's first law, because if acceleration is 0, F net equals m times a, right? If a is 0, so F net equals 0. So automatically going to Newton's first law. All right. So, and lift problems we have. Lift problems we have, guys. For lift problems, we are using on this, you are in on the, just inside the lift, and then you have scale here. You measure your weight. So if you are just going without acceleration with constant velocity, if they said constant velocity or just going without acceleration, you have normal weight, your weight formula, you know, m times g. But if accelerating up, your weight is equal to m times g plus ma. All right, so you see more weight. If you want to see, if you want to be happy, accelerate down, because you are going to see less weight. So m times g minus m times a. And then you are happy because you think you are losing your weight, but that scale is lying you. So it's not true. So mg minus ma. But if you are moving with gravitational force, it means you are falling down, you are going to die. So weight equals m times g minus m times g, and then your weight will be 0. So this is another case. Lift problems like this, in multiple choice questions or maybe short question, they can ask you which position do you feel more weight, or what's your weight is less than normal weight or more than normal weight. If you have more than normal weight, it means you are accelerating up. If you have same with normal weight on scale, if you see same weight, it means you are going with constant velocity. But if you see less weight than normal weight, it means you are accelerating down. If you see 0, it means you are dying. There's something's wrong. All right. So please remember all definitions, all formula. We are using weight equals mg plus ma or minus ma, or directly you can say m times a, but acceleration is negative. You can use another way. It's fine. So this is lift problems we have done. And then Newton's law of universal gravitation. So that's another one. Universal gravitation. So every object in the universe attracts each other. So we using this formula, force equal to g m1 times m2, gravitational force, and then mass on first object, mass on second object. So, but what kind of questions come? Mostly coming like this. If you make double mass, just both masses double, you know, just force increased by 4. Because if you put 2m for each, 2m1, 2m2, what's going on? Let's see. This is your normal force. But if you say g times 2m1 times 2m2 over r squared without changing distance. So 2 times 2, 4. Take from just 4, g times m1 times m2 over r squared. So we know all of them, f, so 4f. just increase by 4. Both mass half, what's going to happen? So 1 over 4, because 1 over 2, 1 over 2, 1 over 4. But distance increased by 4, what's going to happen? So decrease, your force decrease by 4. Do you remember we said just make 1 over 2 and 1 over 2, and then square, just making 1 over 2 square is equal to 1 over 4. But it's coming from this formula. How it's coming, just let's try to explain. If you make double distance, what's going to happen? You are writing 2r. Okay, let's write here. F is equal to F2, we can say. F2 is equal to G times M1 times M2 without changing mass, all right? So 2r square. So what's going to happen? G times M1 times M2 over 4r square. So you can take it, just say 1 over 4 front, 1 over 4 G times M1 times M2 over r square. So 1 over 4. If you just make double distance. If you decrease distance by 3, increase. So if you just increase distance, your force decreasing. Decreasing distance, force increasing. Just remember, as you see, increase, decrease. If decreasing, increasing. Just remember that, but take square, all right? So 2 square is 4, 3 square is 9. You can use that way, easy way, or you can calculate this, up to you. This is Newton's law of universal gravitation. Let's continue with next one. Let's see anything else we have. Yes, from now going to questions. Okay, for Newton's law, number 1, all definitions. Newton's first law, second law, third law, just all types of forces we should know. And then calculating normal force, calculating friction force, calculating tension force, and by using Newton's first, second, third law, and calculating acceleration. Okay, how we are calculating normal force? We did show m times g, or m times g times cos alpha for the inclined system. You remember, right? So all different cases. But when you come to friction force, coefficient number times normal force. But to calculate tension force and acceleration force, you are using Newton's second law. F net is equal to m times a. You can go to your past paper questions. Please try to get all these kind of questions, friction force. So sometimes they can just combine with motion. They can ask you delta x also. Just moving, object is moving up, or using this way, delta x. What are you going to do that time? You are getting acceleration from Newton's second law, and then using equation of motion. For example, v final is equal to v initial plus a times delta t, or delta x is equal to v initial times delta t, plus 1 over 2 times a times delta t square. So all equation of motion you can use and calculate delta x. So we have this kind of things in our mechanics, and then you have multiple choice questions, of course. One multiple choice question, 1 or 2 just multiple choice questions coming. So it is just example for you. Please go to past papers, multiple choice questions, try to get different multiple choice questions. Because of time, I cannot give all examples, but if you can go to our other videos to get more examples, or directly past paper questions, up to you. So now they're asking you, which one of the following force is defined by the statement above? So perpendicular force, yes, by a surface on object in contact with the surface. So answer is normal force, of course, because we know normal force perpendicular to surface. So if you know definitions, easy to calculate this kind of questions. All right, please try to remember Newton's first law, second law, third law, and then you can get. Let's give one more example, and then we have done for today. So this is this question from different past paper, from past paper questions. First of all, let's see our question. 20 kg object you have, yes, inclined system with 30 degrees, and then constant force, apply force is just acting here. We can say apply force. Let's say apply force, all right. And then, okay, constant velocity, it means acceleration is 0. So it's easy one, huh? Sometimes acceleration we have, sometimes we don't have. And friction force also given, friction force 18 newtons, all right. As you see, in long questions, they are asking you one definition. Now they ask you Newton's first law. Next time, maybe Newton's second law, third law, universal gravitation, or acceleration. You know, please try to memorize all definitions and draw a free body diagram, labeled free body diagram. So it means you should show all names. All right, free body diagram. Maybe next time they are asking you force diagram. When you check past paper, please try to write option. Okay, now they're asking me free body diagram. It means next time they can ask force diagram, but there is no another option. All right. So if you study with past paper like this, so 100% you can get good mark. Calculate magnitude of force, apply force. We are going to calculate, and then they said when you remove force, apply force, and then x and y surface. Okay. Frictional force still acting, 18 newtons, all right. Still moving up, y to x, all right. Write down the net force acting, okay. Calculate distance speed. As you see, yeah, that's I do distance. Now they're asking you distance, but next time they can ask you, maybe friction force is not coefficient of friction number they can ask you. So how we can get friction number over normal force? So you must get normal force. How can we get normal force for this system? Do you remember? M times G times cos alpha. Now alpha is 30 degrees. So you can use this one coefficient number you can calculate, or coefficient number is given, let's say 0.5, and then asking you friction force. You know, I'm trying to give all different options. And what else they can ask? Coefficient number times normal force. How we know normal force? From our case 5, right? M times G times cos 30. All right. So what else they can ask? Let's say cos 30 here. And then maybe they said constant velocity. Now next time with acceleration. So they can ask you acceleration. So we are going to calculate acceleration. Newton's second law we are using. M times A. So A is equal to force over mass. You can use this after, or if you have two objects, you can use just tension force maybe next time they're asking. So different questions waiting for you. Please go to past paper questions and then try to get all types of questions. All right. So let's continue with this question. Let's see what they ask. Newton's first law. Okay, Newton's first law definition is here. So you just get it from your, all definition list we shared on our first slide. So Newton's first law, please study Newton's first, second, third, all Newton's laws. So let's continue with next question, 2.2 now. As you see, asking you free body diagram. Free body diagram, how we are drawing what we said. First of all, on the system, please draw all forces. We have apply force here. And then object is going up or down. Let's see first, direction of diagram moves up. Okay, direction of motion is very important because to get friction force, object is moving this way with constant velocity v, and friction force on the surface is here. And then we have gravitational force, of course, normal force. So these are free body diagram, but what we said, they can ask you force diagram. Maybe if they are asking you force diagram, what you are going to do, you're just taking out that box, and on that box, you are showing all forces. So weight or gravitational force and friction force on the surface. Friction force is here. And then we have apply force. Let's say if apply here, apply force. And what else we have? Normal force perpendicular to surface. As you see, just using box here, we can say. But remember, friction force here, and then gravitational force start from center, and normal force perpendicular to surface. Of course, we must label them. All right. So this is our free body diagram and force diagram here. Just check all of them. Two types of diagram we have. On your exam, maybe one of these coming. And then calculate net force. Okay, calculate, so not net force, apply force. Okay, we are looking for apply force. Let's say another question. What else we said? Maybe tension, maybe acceleration. Next time they can ask, please be ready for all kind of questions. Okay, let's continue with next one. We are looking for applied force. We are using Newton's second law and writing formula. One of these is fine. They said you can use any formula. And friction force. Okay, how we are getting this equation? It looks scary, right? So let's just show on free body diagram will help you, of course. We have friction force this way. We have applied force this way. So applied force minus friction force and minus V, it's a W or FG, you can say FG parallel. So F applied minus friction force minus FG parallel, or F applied minus F friction plus. So in brackets, when you open brackets, you can write them all minus. So these are Newton's second law. So to get FG parallel, we are using M times G times sine 30. Okay, for parallel, I'm using this equation, M times G times sine 30 degrees, because our angle is 30. All right, but just in case, just let's see, if friction force is not given, and they are giving you mass, and then let's say coefficient number 0.2, for example. So how you are going to do that time? You need your just W perpendicular, because to get normal force, you need, it is perpendicular, I couldn't draw. So normal, so you are getting friction force like this, coefficient number times normal force is equal to FG perpendicular. So you can write M times G times cos alpha. I hope it is clear. Or let's say coefficient number is not given, but friction force is given here, asking you coefficient number, how you are going to do friction force over M times G times cos alpha. So we can just give all kind of questions, all different questions, but all coming from forces. Newton's laws, all coming from forces. Just take, if you have two objects, it's fine, still same stuff, all right. Separate M1 and M2, and then just get different calculations. If you need, you can combine to get tension and acceleration force. You just combine and get tension or acceleration, maybe both of them. All right, so you are using that. Or second option we have to calculate our applied force. You can use work energy theorem. As you see, work net is equal to delta EK. So using this formula, it's also possible. F applied times delta X times cos 0. Why cos 0? Do you remember work energy topic? Because parallel to direction of motion. Object is going up. If applied this way, same direction. Because of that, cos 0. For friction, we are using cos 180. Why? Because opposite direction of motion. And then for weight, parallel, just weight is parallel here. So we are using that delta X times cos 1. Oh, just another use. Okay, just that one. Leave it for now. Not urgent. If you use F apply is much better. Straight using F weight, and then they said 120. For now, we can leave it this one. And then let's continue with 2.4. 2.4, they said, write down the net force acting on the block. If you remove applied force, what's going to happen? And then you are coming to position X and Y. For this position, what you have now, if object still going up, but there's no applied force, you have friction force here, and then you have weight parallel. So, and then you can say 116, still same force acting, because just moving with, let's see, just continues to move up, surface come to rest at point Y. So friction force 18 newtons. Friction force 18 newtons, still the same. And a direction of forces, because we calculate already weight, just gravitational force parallel and friction force total, we calculated 116 newtons in question 2.3. It's still same, F plus FG parallel is equal to 118 and down. So as you see, direction is still same, but object is going up, but slowing down now because of friction force. Because of it, there's no applied force, slowing down and stop. All right, so we have done question 2.4, and next one, last one for today, 2.5. 2.5 asking you calculate the distance between x and y using Newton's second law to get acceleration. What we said, they can ask you friction force, normal force first, normal force, friction force, acceleration, or tension force, or displacement they can ask. So what we are going to do, what we said, we are using Newton's second law to get what we need. For now, we need acceleration. So you are getting acceleration first. When you get acceleration, you can use Newton's equation of motion to calculate delta x, or V final, or V initial is given. So they can ask you different questions. So we have done our revision. I said quick revision, but I don't know if it's quick or not. So we try to cover most of stuff, but not everything. Please go to past papers and then try to get some different questions to make sure you are getting full mark, good mark. Have a nice day, everyone. See you next lesson.